They're already in Teams. Yeah. These are your lecture slides. Yeah, this is lecture one. Yeah, this is lecture one. Oh, I'm not. Yeah, I'm not gonna re-upload the slides with markings if that's what you're asking. No, sorry. Thank you. Four categories of attacks. Yes, you're absolutely going to have those in there. So interception attack, interruption attack, modification, and then fabrication. If you guys see this is going to be an extra credit question, but you guys will probably, like I said, if there's extra credit in there, you guys will see this. Nothing from here. Probably nothing from here. Human factors, and then obviously nothing from here. That was lecture one. On lecture two, the cryptography classification, that will be in there. Again, we have substitution, right? So Caesar cipher, ROT 13. So you guys will see those in there. No history. Ghost principle will be in there. If you guys recall on the lecture, we went through every single one of them, right? And we mentioned that again. One of them obviously didn't apply, which was number 4. So you don't have to worry about number 4, but all of the other ones should be in there. Know what a one-time pad is, but I'm not going to have you do anything with it, right? So remember that I'm going to give you guys an example in here. Again, you guys are not going to have to do that. Just know what it is. Same thing for the transposition cipher. Know what it is. I'm not going to have you do anything like this. Transposition cipher, same thing. Just know what it is. You won't have to do anything like this. Steganography, actually, the only thing that you will see with steganography, it is going to be what type of files do they use. And those should be obviously the type of file. So anything that is a multimedia file, obviously if you see something like .exe, maybe .py, .c, .go, all of those are incorrect, right? So keep that in mind. Know the difference between these two types of attacks for symmetric encryption. There's a whole lecture on DES. So we'll go through that. So I guess you don't have to really do that one. With triple DES, know that obviously it has 2 different key sizes, right? So 112, 168. It repeats the algorithm 3 times. We went through AES, but again, this kind of summarizes the whole thing with AES. And then this table has a summary of DES, triple DES, and AES. But we're going to go through those as well. Blockchain, so what is cryptography? We will definitely have that one. So those two. Know the difference between symmetric encryption and asymmetric, right? One of them uses the same key, the other one utilizes 2 different keys. What are the 5 ingredients of symmetric encryption? So that will be there. Block encryption algorithms, right? We have these 3 in there. Again, we have a whole lecture on AES, but again, do know AES has 3 different key sizes. Know how symmetric cryptography works, right? So again, you have one key, that key does the encryption and decryption for both. Asymmetric, make sure you guys know again how this works. And this is part of your lab number 3, right, that I was saying. So just know how it works. Again, no history, no history, no history. What is blockchain, right? So I think I asked a couple times, right? The 3 main components of blockchain. So timestamp, append only log, database, and a consensus protocol. So you guys would definitely see a question like this. You guys don't need to worry about this. Make sure you know what a hash is. I don't expect you to tell me how many bits or how many digits, right? The output, but I do expect you to know, again, SHA-1, SHA-2, and I expect you to know the SHA-2 has 256, 384, and 512. Okay? We also talked about SHA-1 being deprecated, and so is anything with MD, right? So MD2, MD4, MD5, all of those are deprecated. We no longer use those. Again, I don't expect you to know this or memorize any. No history, more history, more history, more history, more history. The 2 categories of blockchain, right? So permissionless and permission, so those will be there. Components of blockchain. So hash functions, right? And security properties, those will be in there. You should know what's within a block. You should definitely know what a nonce is. That will be definitely a question on the exam. I don't think there's anything with transactions. Do know that, again, a new block of transaction ID is going to start, right, when you do some sort of transaction. So just keep that in mind. Again, I won't have you calculate anything, but you do need to be aware that again, a new block, right, or new transaction ID does get created. Input transactions will be in there. Output transactions will be in there. Asymmetric key cryptography absolutely will be a huge part of your exam. Yep, asymmetric. Addresses and addresses derivation will be in there. Again, ledgers. The difference between centrally owned ledgers and the blockchain network. What's in a block? Again, you guys should know that a Genesis block is block 0, right? That's as far as I will go with that one, right? Genesis block equals to block 0. You guys should know how this works in the sense of, remember that again, they hash, right, previous blocks. Remember that I gave you guys the example on, hey, what happens if block number 3, right, it's a bad block. So again, you guys should be able to determine, right, how the blocks work. Consensus model, you guys should know that. Proof of work. More proof of work. Again, I don't expect you guys to solve anything. Yeah, no history. Know the difference between soft and hard forks. And that's it for lecture 3. Fisa structure. You guys should know these instructions, right? Data gets split into 2 halves. You have a right side of the data, left side of the data, right? Right side of the data goes into a function. And then along that function, you input a key, right? The output of that function and the key goes to the left side of the data where it gets exclusive OR with the left side of the data, right? So basically, you should know how this diagram works. And that's what I was just explaining, right? So data gets split into 2 halves, right side, left side, right? You have a key, everything goes into a function. The output of that goes into the exclusive OR operation with the left side of the data, right? And then the output goes into the next block. So that's for the Fisa structure. Again, design properties, basically encryption, decryption, right? So same thing. DES, the difference between block and string ciphers. So know what block cipher is. Again, know what DES is, right? And again, notice that DES follows the Fisa structure. So absolutely know DES. So 64, 64, right? And then 64. Remember that this is the master key. But then you have subkeys that are 48 bits, right? So again, make sure you read the question. So what is it asking? It's asking with regards to the subkeys. It's asking with regards to the master key, right? Know what a transposition order is. And again, all it is just rearranging the bits, right? Same thing for this diagram. Remember what happens at some of the steps, right? So for the key, what happens after permuted choice number 1? Huh? Yeah, you lose 8 bits, right? And then again, what happens at permuted choice number 2, right? So you lose another 8 bits. So again, remember those type of things with regards to the DES. And then we went into analyzing around. So do understand this, right? Know what's inside the function, or at least you should know, right? That the expansion permutation is adding bits, right? Again, you already should know what exclusive OR is. These substitution boxes or DS boxes, right? Again, you guys should know what those are. We did the example. Again, I'm not going to give you guys any tables. I'm not going to give you any tables whatsoever. And you may end up having the in-between bits, which is going to be your columns, all right? Again, I'm not going to give you a table, so I don't expect you to look it up, but you should be able to know what 1, 1 equals to in decimal and what 0, 1, 1, 0 it's decimal representation, right? Again, no tables. Again, know that the keys right after they go to permuted choice number 1, they lose 8 bits. Again, all of this is just representation, right, from decimal to binary, and then binary back to decimal. Again, I'm not going to give you guys tables. Yep, no tables. On this one, the only thing that you guys may need to know is this, right? When you're just rotating the bits, so rounds 1, 2, 9, and 16, it's going to be shifted by 1 bit, then everything else is going to be shifted by 2. No tables. All right, then that covers DES.